Hi, welcome back. In this video, we're going to continue discussing asymptotes, but we're going to focus primarily right now on the horizontal asymptotes. These are really easy to do, but before we start, let's remember back in the glory days of pre-cal, when you're talking about a horizontal asymptote, you are talking about in behavior. So let's say we have some horizontal asymptote here. And we want to know really what's happening as x goes to infinity. We want to say as x goes to infinity, as x gets really, really large, we want to find out what the function's approaching. And what it winds up doing, it winds up approaching that horizontal asymptote. So that's really what's happening when you have a horizontal asymptote. We let x get really large, and we want to find out what's happening to the function here. So let's take a look. Well, right here we have our definition of the horizontal asymptote, and that's exactly what it says. As x gets really large, what's happening to our function? We want to know what's happening here. So let's take a look at some examples. So in this case right here, again, it says as x is going without bounds, what happens to the function? And again, in pre-cal, we call this in behavior of a function. So let's see what happened here. This right here is a definition of a horizontal asymptote. This is right here going to be a horizontal asymptote. Now there is a shortcut for these. There's a big mathematical way to do it, but there's a real big shortcut. Because we're going to let x get really large, because x gets large, we really only need to look at what matters the most, and we can ignore the rest. For example, if I look at the numerator, I have this 3x squared, this minus 3x, and the 7. Of the 3x squared, the x, and the 7, which one will grow the fastest? The x squared, the x, or just the constant 7? If you said the x squared, you're exactly correct. So what I can do is I can just rewrite this, the limit as x goes to positive infinity. All I care about is this 3x squared, and on the bottom, this 4x squared. Everything else just goes away for us because when we think about how big these numbers are going to be, that should be a 4 right there. There we go. When we think about how large these numbers are going to be, x squared is much bigger than 3x. So I don't have to worry about that 3x right there because the x squared just takes much precedent over it. So if I reduce this now, please don't plug in infinity, because if I try this, we're going to get infinity over infinity. We would get the limit as x goes to infinity of 3 over x squared. Now what's really interesting is this right here is just the parabola, is just a rational function, and it just looks like this. What does x squared look like? It's going to look something like this in the overall big scheme of things. And that's all it's going to look like because we're only interested in the in behavior, what's happening at the end of the function. And this is really easy to do, but to solve it, we have to make a new rule for us. What is the limit as x goes to 0, or infinity, excuse me, of 1 over x? And we talked about this in the previous video. That's just going to become 0 for us. As x gets really large, the function just goes to 0. So if I have as x goes to infinity of 3 over x squared, that's just going to become 0. So this will have a horizontal asymptote, y equals 0. Very easy to do. So what happens as we approach negative infinity? Well, let's try it out. Same thing. I don't care, I don't care, I don't care. These are all I'm really worried about because I'm going to infinity. We just need to recognize this as a horizontal asymptote. So we would get the limit as x goes to negative infinity of 3 over x squared. When I plug this in, be careful. I'm going to get 3 on top, but you don't want to ever write this. I would have a negative infinity squared. So it's just going to 0. Honestly, 3 over infinity, even infinity squared is 0. Even if it's negative, it's still going to be what? 0. So what this is telling me, we really don't know what's happening at the middle of it. But we do know as we go on forever, we're approaching 0 on both sides. So we kind of know what's happening with the in behavior right there. And again, we don't want to write that right there. We don't want to write that. We just want to go straight to 0. Don't do that. Okay, don't do this. AP can mark that wrong. But very easy to do. So let's try number 1 here. If we were to try number 1, what matters the most on top is I'm going to infinity, so recognize this as a horizontal asymptote, the top and the bottom. So we get the limit as x goes to infinity, 2x over 3x. Oh, look, the x's cancel. And that's just a constant, so that just stays 2/3. Now, this one should look a little familiar. So if you start to think, man, this looks familiar to us, it should. From pre-cal, we learned that if the degree on top is bigger, so if the top is bigger, we have a slant asymptote. But if the degree on bottom is bigger, we said the horizontal asymptote was 0. And if we said the degree was equal, we know that it's just the ratio of the largest coefficients. And that's what we have here. The degree here is the same as the degree in here, so we get that ratio of 2/3. So you can even use those old pre-cal rules; they still work. All right, the next one, same thing. Ready? What matters the most? I got the 3x, the 4x squared on bottom. I don't care about the rest; they just go away. So we got the limit as x goes to negative infinity, 3x over 4x squared. Reduce it. Do not plug in infinity yet. We get 3 over 4x. And again, if I plug this in, I get 3 over infinity. It's even like if it's 3 over negative infinity. And that's just going to become 0. And this does work for our ratio. If the bottom is bigger, we're going to get 0. All right, so let's try number 3 real quick. Number 3, pretty simple. What matters the most? On top is the 2x, and the bottom their absolute value of x. I don't worry about the 1 or 3 because a line grows faster than a constant. So when I rewrite it, I get the limit as x goes to infinity, 2x over the absolute value of x. Now, we got to get a little bit creative here. We don't like absolute value of x, so I'm going to get rid of it. So how do you undo absolute value of x? That's right, it's just plus or minus x. So we're going to get this. The limit as x goes to infinity, we get 2 over plus or minus 1. Those cancel. So the question is, well, which one do we pick? We only want one answer. So I look here. That is positive infinity. So therefore, we pick the positive answer. So we want the positive. So we get 2 over 1, which is just 2. So this has a horizontal asymptote, y equals 2, right there, if you want to write that. So try number 4. How would we do number 4 then? Oh, there, just the exact same. Don't care about those. Those go away. I only care about the 2x and the absolute value of x. We got the limit as x goes to negative infinity, 2x over plus or minus, should show the step. The absolute value of x. Rewrite that limit every time. 2x over plus or minus x. X's cancel. And I can kind of shortcut it now, but this time I want the negative. So I pick the negative, and that's going to give me negative 2. The x's just cancel out. We just follow our directions. Number 5, same thing. What do I care about? What's bigger on top? The 2x. So I get this limit as x goes to infinity. I get 2x over. On the bottom, I get the square root of x squared. Now, we got to be careful. Back in pre-cal, you learned that the square root of x squared is the absolute value of x, or just, again, plus or minus x. And again, I want the positive infinity, so I get that. X's cancel. I get 2. And look how easy this is. Try number 6. Same thing. I only care about the 2x and the absolute and the square root. I don't care about the minus 3 because it just x squared is so much bigger than a constant 3. Like if I have $3 and you have 100 squared dollars, You have way more money than me, so then that 3 really doesn't affect us much. So I can rewrite this. The limit as x goes to negative infinity, 2x over the square root of x squared. Simplifying it, 2x over plus or minus x, but this time we want the negative. X's will cancel, make sure you cancel those, and that just becomes negative 2, or 2 over negative 1, which is negative 2. Graph these on a calculator, look really kind of freaky. All right, keep on going on. All right, let's have some fun. What happens if the degree on top is larger? Well, let's think about what happens. I don't, again, over here, I only care about the, oops, sorry about that. The 2x cubed and the x. Because the others just don't mean much. Because as x gets really large, 2x really doesn't affect as much as x cubed will. So we get this, the limit as x goes to infinity, 2x cubed over x. Now notice I can reduce it. We get 2x squared. Plugging this in. Now if you notice, this is just a parabola. What this is saying is that in the end, this is just a parabola. It's kind of like when you did your slant asymptotes last year, or your oblique asymptotes when you did rational functions. If I plug this in, I'm going to get 2 times infinity squared. Don't ever write this. We don't write that, but we can do that mentally by saying, oh, that's just infinity. 2 times infinity is just infinity. The next one, we take the limit as x goes to infinity. You got to recognize the horizontal. I got 3x squared on top, 5x on bottom. I can reduce it. Now notice, this is just a line. 3 over 5, 3x over 5. That's just a line, 3/5 x. If you plug in the infinity, what is it? 3/5 times infinity, but infinity. So there we go. Number 9, same thing. There's my infinity. That's all I really care about. Because I'm going to negative infinity. I want that horizontal asymptote here. So when I rewrite it, the limit as x goes to negative infinity, and I can reduce it. I already did it before. Plug in negative infinity now. Now we get 3/5 times negative infinity, and we get negative infinity right there. All right, let's try number 10 real quick. For number 10, the same thing. We only go into infinity, so I don't really care about the 6 on top because 3x squared takes much bigger, and the 5 on bottom, same thing. So we get the limit as x goes to infinity, the square root of 3x squared over negative 2x. Oh, this one's kind of fun. I'm going to separate the square root of 3 and the square root of x squared. Keep on going. Now you don't have to do this in so many steps. We get the square root of 3. Remember, this is just plus or minus x is the square root of x squared over negative 2x. Oops, got my x here. X's will cancel. So what I'm left with, and remember, we're going to a positive infinity, so I pick the positive x up here. So the top is a positive root 3, the bottom is negative 2. We get negative root 3 over 2. All right, hope you enjoyed this video. Go to the next one. We're going to take a look at some a little more challenging ones, more fun ones. Okay, I'll see you then. Bye-bye.